In the mid-1990s, various US carriers raised an antitrust case against American Airlines and United Airlines. The complaint was that online search systems were biased against foreign and domestic carriers. Their case focused on the algorithms used in ticket reservation systems. These systems prioritize flights that use the same carrier for all the legs of a trip. This meant that an agent searching for a ticket from Louisville, Kentucky to London, going through New York, would see flights involving no change of carrier higher on the list than flights involving two different carriers. Since in the 90s, screens showed only 4 to 5 flights, and 90% of all bookings came from the first screen, small differences in ranking had big financial implications. As this airline reservation example shows, algorithms are not always fair. In fact, algorithmic bias is now a prevalent topic of discussion in computer vision systems, university admission protocols, natural language processing, recommender systems, courtroom risk assessment tools, advertising, and finance. But much like human biases, algorithmic biases are not simply the result of maleficence. They also emerge from both practical and fundamental considerations. On the practical side, both people and machines learn from data that are often biased and incomplete. Biased data can lead to biased learning and behavior. But even with nearly perfect data, guaranteeing fairness may not be possible. Fairness is a concept that can be defined in multiple ways, and it is not always feasible to satisfy multiple definitions of fairness simultaneously. Consider two populations, A and B. A and B could be people identifying with different genders or belonging to different nationalities, age groups, or ethnicities. For the purpose of this exercise, the type of difference or its source doesn't matter. What matters is that we want to achieve a fair outcome when it comes to our treatment of both populations. But what is a fair outcome? To keep things simple, consider two definitions. The first definition is known as statistical parity or demographic parity. This means guaranteeing that outcomes affect equal proportions of A and B. The second definition is equality of false rejections or equality of opportunity. This means guaranteeing that the probability of being rejected if you are from population A or population B is the same. In principle, we can satisfy both definitions by considering an outcome that doesn't hinge on a selection criterion. For instance, giving concert tickets at random satisfies both statistical parity and equality of opportunity, as long as the fans of the band are equally distributed among both groups. But if they are not, distributing tickets at random would be unfair for the group that includes more fans. Fans in this group would get fewer tickets and be more likely to be rejected. Instead of free concert tickets, consider loans, admitting students to college, or giving someone a promotion at work. These are all cases that are more delicate and also that imply some degree of selection or merit. Imagine populations A and B to be of the same size but have a different probability of paying back a loan. To keep things simple, assume that 40% of the people in A will repay a loan, but only 20% of the people in B would. We can achieve a statistical parity by giving loans to 20% of the people in A and 20% of the people in B. This would be fair, but would violate equal opportunity. If we enforce equality of opportunity, we will give more loans to people in Group A, but we will violate a statistical parity. This shows that even in simple examples, satisfying multiple definitions of fairness cannot be guaranteed. This is not because fairness cannot be defined, but because it allows multiple definitions. In this particular example, we use only two, but we could have used many more. Fairness is a complex concept that accepts multiple definitions. In most cases, these definitions cannot be satisfied simultaneously. This means that the world is unfair, not only because people and machines are biased, but because it is often impossible to satisfy multiple definitions of fairness simultaneously.